Input stepper is the default number picker on most smartwatches. Flicking up increases the number by 1 unit. Flicking down decreases the number by 1 unit. Flicking fast increases the pace of the increment or decrement in relation to the pace of the flick. We introduce 3 new number pickers for smartwatches: swipe-based, tilt-based, and force-based. The swipe-based method enables number picking by performing up and down swipes on the screen. Swiping up increases the number by 1 unit. Swiping down decreases the number by 1 unit. Swiping then holding the position for 850 milliseconds activates continuous increment or decrement. The pace of the increment or decrement changes in relation to the length of the stroke. The tilt-based method enables number picking by twisting the wrist towards or away from the body. Twisting the wrist up increases the number by 1 unit. Bringing the device back to its initial position stops editing. Twisting the wrist down decreases the number by 1 unit. Holding a position for 850 milliseconds activates continuous increment or decrement. The pace of the increment or decrement changes in relation to the angle of the tilt. The force-based method enables number picking by varying contact force on the screen. Applying extra force then returning to the regular force increases the number by 1 unit. Applying soft force then returning to the regular force decreases the number by 1 unit. Holding a level of force for 850 milliseconds activates continuous increment or decrement. The pace of the increment or decrement changes as time progresses. The new methods enable editing numbers directly in text. For inline editing, a magnifier window pops up when the finger is near the value so that users can see it changing. We compared the default and the 3 new number pickers in 2 user studies. The first compared the 4 methods in stationary and mobile settings. The second compared them with individual and inline numeric values. The swipe-based method was significantly faster than the other methods in both stationary and mobile conditions. Participants found the default picker and the swipe-based method substantially faster, more accurate, easier to learn and use, and were willing to use these methods in both stationary and mobile settings. Participants also found the default picker and the swipe-based method to be the least mentally and physically demanding and the least frustrating. The swipe-based method was also significantly faster than the other methods in both individual and inline conditions. Participants found the default picker and the swipe-based method significantly easier to use. Besides, like the previous study, they found the default picker and the swipe-based method to be the least mentally and physically demanding and the least frustrating. In summary, the swipe-based methods was significantly faster than the other methods in both stationary and mobile settings, and with individual and inline numeric values. Participants found the default picker and the swipe-based method significantly easier to use in both studies. Participants also found the default picker and the swipe-based method to be the least mentally and physically demanding than the tilt-based and force-based methods in both studies.